Alright, hey everyone. Today we're going to get through the dual nature of light and matter. So, actually, a really quick lesson today. We're here in the notes, but we're here in the notes, but I'm going to sort of go through using the PowerPoint just because it was easier for me to write that way. Okay, so we'll start with the dual nature of light right up here. So, what actually is light? And so far, you've just been kind of like doing it based on what I said. What I mean by that is we started out saying that light was a wave, right? And basically, because I told you to, it has a frequency and a wavelength, and those are wave things to be doing. But also, I started telling you that light is a particle. When we started talking about photons, and those two things should sort of like cause a conflict for you. Particles and waves are different things. Like waves do wavy things, and by that I mean they diffract when they bend when they go through openings or around barriers. Light interferes, so like when two waves collide, they can constructively interfere and make a bigger one, or destructively interfere and cancel out. Particles don't do any of that. Like particles are just everyday objects, like objects that get in collisions and bounce off of each other, or maybe stick together. They don't interfere when they collide. So those are two, waves and particles are two completely different things. But I've kind of been telling you that light is like both of them, depending on the situation. So today we're going to kind of figure out what light actually is. And the answer is way more complicated than probably needs to be. But it's just the way the universe works. So the dual nature of light. What is light? Well, light is both a particle and a wave. It is both of these things, kind of depending on like what you're watching it do. Sometimes it'll do particle type things. Sometimes it'll do wave type things. It's if I'm trying to explain what light actually is, the answer is that it's this really hard to imagine or conceptualize type thing. It's kind of this wave that goes back and forth. It's kind of this particle that hits things and smashes into them. So it's both of these things. How do we know that? Well, we do some experiments. We do experiments to see if it does light things. We do experiments to see if it does particle things, and we see what comes out. So, evidence that light is a wave. Let's start with this. This is a very famous experiment done by a man named Thomas Young. He sets up what's called the double slit experiment. He tries to prove that light diffracts and interferes just like a wave. Basically, if waves diffract and interfere, and light diffracts and interferes, then light must be a wave, because that's what waves do. So he sets up this thing called the double slit experiment. Basically, what he does, he sends a bunch of light waves in between these two openings that are very small. If the light goes through the opening, they diffract through the opening, meaning they bend. So you can see these like semicircles of each different wave bending once it goes through the opening. When they do that, they overlap. Notice this large region in the middle where the two waves are overlapping, and he puts a screen in the back. And on that screen, remember, we're shooting light through it. So if the light hits the screen, it should be bright because the light hit it. Now what he notices on the screen is that it has this sort of alternating pattern of bright spot, dark spot, bright spot, dark spot, bright spot, dark spot. And it's the result of these waves as they're diffracting and crossing over one another, interfering constructively and destructively, and then constructively and destructively. And that's the double slit experiment. Shown a little bit differently, we've got this. So here's what we're going to do. This is our double slit. We've got these two openings in our barrier. You can kind of see them. And if I clear the waves, and if I send waves through, notice that they sort of bend as they go through, and you end up with a pattern that looks kind of like this. It's a little tough to see here, but if we go into sort of 3D mode, we're going to ignore this whole mess in the back because it's kind of muddying up the picture. But if we look at right here, notice that, we've got the two openings that you can see, and the two waves sort of bending when they go through those openings. And in this region where they overlap, see these spots where these sort of lines that extend outwards where it's completely flat? Those are places where destructive interference is occurring. And since he does this experiment with light, well, if light cancels out, what you would notice is darkness. And so, sure enough, he puts a screen kind of like where the mouse is, like the part that's towards you. He puts a screen there, and he notices that there's a dark region here, and a dark region here, and a dark region here, because there's destructive interference happening there. And then here, where notice the waves are very high, he notices bright spots there because there is constructive interference. So again, the light comes in, it bends through these two openings, and it just sort of naturally creates we call it an interference pattern. These dark spots and light spots, and then dark spots and then light spots. And again, all of that is just a result of the light bending once it goes through the opening, and then interfering as the waves overlap. And again, since that's a wave thing to do, and light does it, light is a wave. And so he successfully proves light is in fact a wave. Whoops. But then other physicists do sort of experiments that prove that light actually can often behave like a particle. This is an idea that they have. So Arthur Compton finds this phenomenon called Compton scattering. And it's kind of weird, but I guess the short version is photons can collide with electrons as if they were particles. So light can hit an electron, and this scattering thing occurs. We have light, kind of like our drawing right here. Light comes in, it hits this photon, and the photon it hits an electron. The electron will go this way, sort of towards bottom right, and the photon will go this way, towards top right. But collisions are a thing that particles do, and so we can sort of model this collision using things like momentum, and momentum's a distinct characteristic of particles. So this experiment proves that light is also a particle. And the photoelectric effect does this as well. Again, I'm going to get the real short versions of this. But this idea was developed by Einstein. He proves that photons, which again is particles of light, so this whole thing hinges on the idea that light is these particles, can cause electrons to be emitted by some materials. So here we've got like light coming in, it's the squiggles, and they can cause electrons to be sort of ejected from the material. And again, the important part is that this whole thing is based on the idea that light is a particle. So to answer the question, like, what actually is light? It's so much more complicated than, like, it's a wave or a particle. It, like, depends on what you're looking at it do. If you're looking at it diffract and interfere, then it's a wave. If you're looking at it do these collisions or this photoelectric effect, it's a particle. It is both of these things. And if there's anything I want you to get out of this, I know I gave you, like, a lot of half explanations of these experiments. If there's anything I want you to get out of this, it's that light is both a particle and a wave. It is both of these things. Which brings us to sort of the next question. So that's light, right? That's what you see. That's these electromagnetic waves. But what are like particles themselves? Like, what is matter itself? And it turns out that matter itself is more complicated than this. So the dual nature of matter. So what we can do here is we can take matter and let's put it through a couple of the same experiments that prove that light was a wave. Specifically, the double slit experiment. So what we'll do is or what physicists can do, they put electrons through the double slit, basically. We take a beam of electrons, we shoot them through these double slits, and we see if they diffract and interfere. If they diffract and interfere, then they're also waves. And sure enough, electrons diffract and interfere, and we end up with that same interference pattern of constructive, destructive, constructive, destructive. And the important idea here is that all electrons are kind of waves then, in addition to being particles. And that's actually like a crazier thing than light, because like you're made of electrons. So electrons do this. Diffraction interference can also be shown with larger particles like neutrons. And again, you're made out of those things. So then you yourself are kind of a wave as well, which again shouldn't make sense to you. Because if you were a wave and you crashed into someone who was a wave, the two of you would like interfere and cancel out and like you'd be gone. And that would be very strange. It wouldn't make any sense. But this idea, it holds up. It really only holds up, though, if you look at small objects, like electron-sized objects. Again, it works with things like neutron size, which would be bigger, but you typically don't see like a person-sized object be able to show these wave properties. So again, matter itself, particles. If you're trying to picture what these particles are, and you're picturing like most people do, like an electron is like a ball that orbits like a nucleus, like something like that. That's not quite what it is, because it's also this wave thing that can interfere and do all of these other things. So light is a particle and a wave, but then matter itself are both particles and waves. And That's the idea. So it's a very strange sort of thing. But again, if you get anything out of this, light is a particle and a wave, and then matter itself, though typically on a small scale like electrons, are also both particles and waves. So we call that the dual nature of light and the dual nature of matter. They both kind of behave like these two different things.